This video is on how to find the important pieces of information from a parabolous equation. And this one is different from the previous videos in that we're starting from standard form. Standard form is what you see in front of you. There are no parentheses. It is simplified all the way. And even though it's simplified, this actually makes quite a few of the steps actually more difficult. But this idea is still that we find the vertex, the line of symmetry, and the intercepts. Let's look at a simple example to start with. As far as this version goes, it doesn't really matter where you start, whether you're looking for the vertex first or the line of symmetry or the intercepts. I usually try to start with the intercepts. There's nothing right or wrong with this method. It doesn't make it any easier or harder. It really depends on which problem you're looking at. So I look for the intercepts first. I do believe that the y-intercept is the easiest when it's in this form. When you plug in 0, you can look at this on your table and your calculator as well. But when you plug in 0, you always get the last term. So it's just -2. The x-intercepts, again, you could look at a table and hopefully they'll be in there. But if they're not, then you would try to factor or use the quadratic formula, or you could look at the graph in order to discern where the intercepts are. I'm going to go ahead and do the factoring method. I always try that first because that's what I'm best at. And this one does factor. And if you're confused about factoring, you can watch the video on that. But when I solve this, I'm going to get +2 and -1 as the two x-intercepts by using the zero product property. And again, I'm skipping over those steps, but that's been discussed in earlier videos, so if you need that, you can go back and watch the previous videos on that. So I have the y-intercept and the two x-intercepts. Sometimes you'll find that those are more difficult to find, but I'm done with those. As far as the vertex goes, one way to do this would be to find the average of the two x-intercepts. However, if there aren't any x-intercepts, which is a possibility, I need to have another method. And the method we've gone over is to complete the square. So I'm going to go ahead and complete the square on this equation. When I do so, I find that the square is x minus 1/2 or 0.5 in each direction. And then I have to find what's left over. So if you need more help with completing the square, you can watch that video. However, what we have left over, I'm kind of imagining the rectangle or the square in my head. What I have is I have x and x, -0.5. So my generic rectangle ends up being like this, and then this last term is 0.25, which when I look at what I have left, minus 2.25 to have it consistent. And again, I know that I didn't show a lot of my work for this. If you need help with completing the square, go ahead and watch that video. But by completing the square, I can always come up with the coordinates of the vertex, which in this case are 0.5 and -2.25. And again, just as a reminder, where I got that from, this is how much the parabola has been moved to the right. And I know that's always opposite of what I'd expect. Minus 0.5 is actually moving to the right 0.5. And then that minus 2.25 at the end means it's moved down 2.25 from the standard parabola. Then again, the line of symmetry is always just x equals whatever the value of the x coordinate, the x part of the vertex, 0.5 in this case. Let's go ahead and look at a less simple example. That one would be y equals x squared minus 6x plus 12. Oops, not sure what happened there. And again, it doesn't matter what order you start with, but I like starting with the intercepts just because I know every time that I can very easily find the y-intercept, even though the x-intercepts are often more difficult. Again, usually we have two x-intercepts, so I'm looking for those. The first thing I try to do would be to factor. When I try to factor this, however, I believe that it does not factor, if I did my problem correctly. So when I try to do the diamond problem, it won't work out. So factoring doesn't work, too bad, because that's my favorite way of solving these problems, but can't do it. My next option would be the quadratic formula, or another option would be to look at a graph. When I graph this parabola, which hopefully you've already done by entering it in the calculator, you'll find that there are no x-intercepts. I just draw a sketch of what I see on my calculator. That's just a quick sketch. Hopefully that matches what you see. The vertex is above the x-axis and it faces upward, so it's never going to cross the x-axis. So what I need to do in this case is I need to say something to prove that I know what x-intercepts are, I've looked for them, and I know that there aren't any. So that gives me a note when you take your quiz, yes, I know what I'm supposed to be finding, there just aren't any. If you leave it blank, I don't know whether you have not found any or whether you don't know how to find any, so that tells me that you know exactly what you're doing. Next thing we do is to find the vertex, and you could certainly start with this, but the idea is to complete the square. When I complete the square on this, the square is x minus 3 squared. I'm picturing the 6 x's that I have that are negative on each side. Let me draw my generic rectangle really fast. Since I have to split the x's in half, this is what works out. And then what I have to complete the square, I need 9 singletons. Now I have a total of 12, so to get this to be an equivalent expression, it would be that. And again, to make sure you have the right thing, you could type the first equation without parentheses in your calculator as y1, and the second equation in your calculator as y2. And if they match up to be the same parabola, I know that I've completed the square correctly. Okay, so I have a couple different equivalent equations that are the same parabola, but the second version, the standard version that I turn this into, is really easy for me to see what the vertex is. It's 3, 3, because again, it's opposite the h value and the same as the k value. And the last step, which I believe is easiest, you pull out the x value of the vertex, and it's just x equals 3 for that vertical line of symmetry. All right, go ahead and pause the video and try these on your own. All right, let's go ahead and see how you did. I have the equations written down here, and I am going to just put up the answers. I'll talk over my work as I do this. For the first one, the y-intercept is pretty easy when you plug in 0, and you can also see that on your table in your calculator if you plug it in. So 2 pretty easy ways to do that. For the x-intercepts, those will also be in the table for this particular one. And I saw them at positive 1, 0 and negative 1, 0. If you couldn't find them, again, you could factor. The vertex for this one. Well, I complete the square, and this is kind of an interesting square because there aren't any x's in this. So this makes it a little bit harder. But the square for this one would just be x by x because there aren't any x's that I need to put in there to complete it. So I don't know whether this one would be really hard for you or really easy for you because of that. But the idea here is that when I turn this into standard form, I don't really need any parentheses. But if you think about it, it would look like that. Let me erase my generic rectangle. It's a little bit too close. So what that tells me is that the vertex is at 0, negative 1, which just so happens to be the same as the y-intercept. This is definitely a weird one in that way. And then the line of symmetry is x equals 0, since I'm just pulling that out of the x-coordinate of the vertex. So again, I'm listing this right here as my y-intercept, and this right here is my vertex. Even though those both happen to be the same point, I do need to list it twice and say what they are, since that's kind of confusing there, since they're the same. All right, the next one. Y-intercept is 0, negative 2. When I try to factor this one, I am unable to factor it. However, it looks like from the graph that there are two x-intercepts, which is unfortunate because factoring is my favorite way to find the x-intercepts. For this one, what I would expect you to do is to be able to estimate what they are. We'll go over the quadratic formula in a few chapters. If you want to do that, that's a great idea. But for now, all I'd expect is a pretty good estimation of where the x-intercepts are. And what I always do to estimate is I zoom in on my graph. So what I think you should have is something, just drawing a sketch here, something that should look like this. So what you want to do is you want to zoom in on, I'm going to highlight the two x-intercepts in green. You want to zoom in on those points and get pretty close to estimating what they are. So when I do that on my calculator, I need to do it in front of myself right now. Typing it in right now, y equals x squared plus 5x minus 2. I'm going to go ahead and look at the graph and zoom in. And what it looks like for me, this point right here looks like it's pretty close to negative 5.4 comma 0. And what it looks like over here when I zoom into that one is about 0.4 comma 0. And that's good enough for me. That isn't exact. You can find the exact answers by using the quadratic formula. But that gets me close to what the two x-intercepts are. I guess I'll copy them over here. All right, I'm going to go ahead and erase that sketch. That was just showing you what I would do on my calculator. The next step is to find the vertex. And again, the way that I would do that is to complete the square. This would be x plus 2.5 squared. And then what's left over, I'll actually have a quarter of one left over when you draw your generic rectangle. But you should have negative 8.25. So that means the vertex is at negative 2.5 and negative 8.25. And again, if you need help completing the square, I'd watch that video because otherwise you look at those and you say, where the heck did I get those numbers? Unless you complete the square, it's really pretty impossible to do so. So I have the y-intercept. I have the two x-intercepts. I had to estimate using my graph for that, or you can find them exactly by using the quadratic formula. I have my vertex that I found using completing the square. I have my line of symmetry that I used by just pulling out the x-coordinate of the vertex. So, are you able to find all this important information of this parabola? Can you do it now? If you can, great. If not, then watch the video again, or ask me for help in class, or do some extra practice problems, something else to keep working on this